The Reactance of Capacitors and Inductors by Max Harwood. Firstly, let's go over some background. Capacitors. Capacitors are electrical devices that are used to store electric charge and voltage in a circuit. They are represented by capacitance, the ability to store charge. The larger the capacitance, the more charge can be stored. It only takes a certain charge in the capacitor takes a certain amount of time to accumulate, and this time period is known as the charging phase. By the end of it, it's known as a steady state, and when this occurs, no current can flow through a capacitor. Inductors, on the other hand, act like a storage system, much like capacitors. However, they store their energy in a magnetic field as opposed to an electrical field. Inductors oppose sudden changes in electrical circuits and are represented by inductance, measured in henries. Inductors function the same way as capacitors with a charging period and a steady state. However, unlike capacitors, when initially started, the inductor acts like an open circuit, but at steady state, it acts like a short circuit. Alright, let's move on to reactance. Reactance is the opposition to current in an AC circuit. Greater levels of reactance leading to smaller levels of current for the same applied voltage. The reactance of certain components can be measured to help understand a circuit's features more broadly. There are two types, inductance and capacitance, each represented by the symbol X. It is very similar to resistance, but varies with the frequency of an AC voltage source. Therefore, it can only be used with AC circuits. The reactance of conductors is measured in ohms, and it has the symbol XC. The capacitance level increases due to the loss in frequency and decreases with a rise in frequency. Inductors, on the other hand, are also measured in ohms. However, they act the opposite of capacitive reactance, falling when frequency decreases and rising when frequency increases. To calculate reactance, there are two formulas that we can use. First of all, the formula XC equals 1 over 2 pi times F times C, with F being the frequency and C being the capacitance. This is for capacitive reactance. Then for inductive reactance, you have XL times 2 pi times frequency times inductance. Alright, let's go over an example. So let's find the capacitive reactance of the circuit and the inductive reactance of the circuit. So here's a basic circuit. First of all, we're going to look for the frequency. So if you look at the bottom, we have V equals 30 sine 1000 t. So our 1000 is our frequency. Next up, we're going to use our formulas from the other page to solve for the inductive reactance. So using 2 times pi times L times frequency, which L being 50 millihenries, that gets us a total of 314 level reactance. Then, doing the same for capacitance of 1 over 2 pi times capacitance times frequency, we get a total of 795 reactance. So, thank you for watching, and yeah.